day, ladies and gentlemen. Thank you for your attendance in this session. In this event, I will present the paper entitled Determination of Household Green Waste Fractions to Methane and its Economic Value. The paper is authored by Joelianto from Institut Teknologi Bandung and Edyson from Parahyangan Catholic University, Indonesia. The presentation is divided into 7 parts: introduction, material and methods, research methods, mass methane and total solid calculations, data processing with software, result and discussion, and conclusion. An increase in population has occurred very rapidly, and it is followed by a rapid increase in the amount of household waste with a lot of green waste proportion. This waste from complicated problem considering that there is no sophisticated waste management system, especially in Indonesia right now. The solid waste treatment system currently in use is open dumping. Management of this method raises a variety of problems, such as a very pungent odor, the need for a very large area of land for its storage, unpleasant sight, health problem to community because of the pile. The open dumping waste management system causes problem everywhere. The landfill produces a large amount of methane gas emission. Methane is one of the compounds classified into greenhouse gases. Methane gas emission have an effect on temperature increase reaching 20 to 25 times higher than carbon dioxide emission. The molar concentration of methane gas in the Earth's atmosphere in 2011 reached 1,803 ppb. Methane gas generated from landfill at the final disposal site (FDS) can apparently be used as a new energy source. This methane gas can be stored as electrical energy to be converted to generators. The converted energy is stored in the form of direct current (DC), such as batteries. Developed countries are fully aware of the potential of waste to be processed into new energy sources. They have done research and the research continues today. As for developing countries, including Indonesia, it is too late to realize this. In fact, developing countries actually have an increase in population greater than developed countries, which means that the amount of waste is increasingly rapid too. Research that has been done in Indonesia focuses more on the optimal conditions that must be used so that the biogas production process can take place effectively and efficiently. In reality, setting the condition as is done in the laboratory today, it is less likely to be applied directly at the final disposal site. Communities will not be able to regulate pH, temperature, pressure, and other operating conditions when disposing to piling up garbage in landfills. The existing technology in Indonesia does not allow for the regulation of operating conditions in the landfill. The above problem causes the process of methanation of waste is still less well known and not fully utilized by the people of Indonesia. Until now, studies on energy conversion have used quite complex calculation. This is a source of new problems, where the community becomes difficult to accept and understand the potential of this new energy source. Knowledge of the process of methanation of waste is needed to create a new awareness that is turned out that waste can be treated simply and produce no small amount of profit economically. This paper considers the calculated of solid waste fraction of green waste collected from traditional market to methane. This value is then used to calculate the amount of benefit that can be obtained from waste treatment by anaerobic fermentation. These benefits come from the use of methane as a source of electrical energy, and compost sales profit from fermented residual waste. Material and methods. The raw material used in this paper is green waste taken from waste disposal site at the traditional market at Simpang Dago Market in Bandung, Indonesia, located with latitude and longitude location -6.884072 and 107.613951. The waste represents the real condition of the waste that will be delivered to the final disposal site. The following figure shows the diluted green waste taken from the market. To conduct the experiment of methane released from the waste, the equipment used in this research is to support in conducting total solid analysis. The equipment consists of porcelain cup, digital scale, oven, stirring rod, glass bottle with a volume of 1 liter as a biogas reactor, plastic hose. Research methods. This research was conducted in 3 stages, namely preliminary research, primary research, and data processing using Excel software. The procedure for calculating total solids from green waste can be seen in the following figure. The dilution procedure for feed is described in the next figure. The procedure for analysis total solids from green waste residues can be provided by the equation which will be displayed later. The following figures show the procedure for diluting the bait in the form of leftover green waste. The main research was carried out by varying the amount of total solid, that is, without treatment, diluted a value of half of the initial total solid, and diluted to a value of a quarter of the initial total solid. The acquisition of biogas volume is measured by calculating the area of the volume of water increase in the hose. Pictures of equipment tools can be seen in the following figures, and the main research procedure can be seen in the next figure. The following figure shows main research procedure. A typical biological reaction as described by the main component of biogas consists of methane, carbon dioxide, and hydrogen sulfide. Methane is a non-polar compound and has a very low solubility in water at room pressure and temperature, while carbon dioxide and hydrogen sulfide have polar properties, so they tend to dissolve in water. The solubility of carbon dioxide and hydrogen sulfide in water is used in the design of water scrubbing to reduce the content of both compounds in biogas purification. In this paper, it is used a hose filled with water which also functions as a column water scrubbing to absorb carbon dioxide and hydrogen sulfide, which are formed as side compounds. Methane with very low solubility in water is assumed to be completely retained in the fermenter so that it does not dissolve and does not diffuse into column containing water, whereas carbon dioxide and hydrogen sulfide are assumed to dissolve completely into water and diffuse into free air at atmospheric pressure. The effectiveness of water scrubbing in reducing carbon dioxide and hydrogen sulfide content is not discussed in this paper. The volume of methane produced can be obtained from the difference in the height of the water in the hose before and after the experiment is carried out. The equation is given by the following, and the methane mass is then obtained by entering the volume value of methane into the van der Waals equation, the following. And the moisture content in solid can be determined by calculating the total solid of the sample. The equation used in the calculating total solid is given by the following equation. Data processing is performed to analyze whether waste processing with parameter obtained from the main research is economically beneficial or detrimental. Other parameters needed to process the data were obtained by gathering information from the Bandung city government, previous research, and other relevant resources. Operating conditions, the assumption used in this processing data are the price for each ton of methane gas is $5 per CO2 equivalent. Waste entering the landfill is not subject to special treatment. Circumstances that the landfill in the form of daily condition in the form of pH in the range 6.7 until 7 and temperature in the range 30 to 45 degrees Celsius. Other parameters used in this experiment were obtained from the result of previous studies and from the survey literature in Thailand. MSW, municipal solid waste, represent the amount of waste received by landfills used in tons per year. Comparison of molecular weight between methane and carbon dioxide is 16 compared to 12. Global warming potential. This price shows the conversion factor from methane to CO2. Methane GWP is worth 21. Result and discussion. Several factors influence the process of biogas formation. To illustrate, temperature, pH, COD value, comparison of carbon and nitrogen value, type of starter, and total solid. In fact, quite a lot of obstacles are encountered when having to control this factor in the field. Therefore, total solid is used as the only factor that is considered sufficient to influence the methanation process. Another reason for the choice of total solid is that the rainfall that is quite volatile in Indonesia causes the total solids in waste in cities to change in value. Acquisition of methane with total solid as a trial variation is given in the following result. The following graph shows the profile of the different in fluid level changes due to formation of methane with respect to time of observation. It is given by the following figure. Show the comparison of liquid level curves of methane production for sample with various dilution. From the graph, the acquisition of methane over the time of observation form on S-curve. At the beginning of the observation, the rate of methane form is quite slow. The rate of methane formation has increased quite rapidly on the 3rd day to the 18th day, which can then slow down again in the following day. At first glance, the change in total solid to half and a quarter on the initial conditions show the result, which are quite influential on the rate of methane production. At lower total solid, the curves that are formed are more linear, where the rate of methane that is formed is fast enough in the initial stages. In the final state, the characterization of the curves that occur are the same as the condition without dilution. That is, the rate of reaction seems to slow down. The conclusion above is only done with a rough approach. A detailed discussion of the reaction rates due to a difference in total solid is not elaborated further because it is beyond the scope of this research. From the final height of the curve above, the calculation is based on the volume of the tubular water hose so that the volume of methane form is obtained. The conversion of methane volume to mass is determined by using the van der Waals equation. This is because the research does not discuss in detail about the molecular properties of methane. Another reason for the methane is the simplest and non-polar hydrocarbon compound, so that the use of more complex equation does not give much different result. The final acquisition of the volume of methane form has increased significantly with a reduction in total solid. For the observation show a reduction in total solid from half to a quarter, giving the same final result. Subsequent calculation of use the smallest percentage of methane acquisition from the experimental result, which is equal to 0.12% as an average result in experiment without dilution by duplication as shown in the table. This is so that the result obtained next show the minimum benefit that can be obtained from the organic wet waste methanation process. This is given by the following table. And this graph shows the waste composition based on the Bandung City condition in 2006 until 2007. Every year, the volume of waste in the city of Bandung has increased significantly. Each resident has the potential to produce 3 liters of waste per day. Of the total garbage in Bandung, around 66% come from the household. Industry is the second waste producer with production of 11% per day, followed by the market waste, commercial waste, and garbage from the sewer. Such a lot of waste, when processed properly, can produce benefit in various ways. Methane gas produced from an anaerobic fermentation can be used further to be used as electrical energy. Residue from the fermented waste can be processed into compost. And calculation of the energy production by using the following condition. The price of electricity used is 720 rupiah per kilowatt hour. This price is the price of electricity for housing in the Central Java region with 900 volt ampere power. In this calculation of electricity production, there are several other factors which are not taken up in. For example, the capital cost of waste conversion technology are not included. Another factor which is quite influential is the variety of electricity prices in Indonesia. Calculation of compost production by following the World Bank that issued the standard for the quality of compost product with the parameter listed in the next table. Anaerobic waste management is actually not dangerous as long as it is done properly and structured. Even processing this way yields additional benefit from the methane gas produced. This is the standard from the World Bank for compost product. And from the previous report years ago, there were 225,017.40 meter cubic of waste accumulated from unloaded waste. Of this large amount of waste, only 75 meter cubic is recycled and composted. Meanwhile, the rest is thrown away without further processing. The paper showed that the biggest benefit gained from anaerobic organic waste processing turns out to be the production of compost. In the compost production calculation, a composting factor of 0.4 is used. The weight of compost obtained is only 0.4 out of the total waste produced by compost because the weight of the waste will shrink during composting process. The value depending on the methods of processing the compost itself. As conclusion, the paper discusses the determination of solid waste fraction of green waste which can be released as methane. Under condition without setting physical parameters such as pH, CN ratio, temperature, the fraction of organic waste that can be released as methane ranges from the range of 0.11% to 0.18%. The economic potential of anaerobic organic waste processing was gained from the electrical generation and the compost production. Adding water content to organic waste will increase the acquisition of methane to a certain extent. The solid waste fraction of green waste can be optimized by making an appropriate setting for a number of physical parameters.